Hello and welcome to my lesson series. My name is Ben and I'll be covering acids, bases and salts. This lesson I'll be covering what an acid is, start on the pH scale, discuss the reaction of an acid with a reactive metal, and establish the distinction between concentration and strength. So let's dive in. First thing to discuss is something called the pH scale. This is a measure of how acidic a substance is. For example, at a pH of 1 are the strongest acids, where at a pH of 6 or 7 there is almost no acidity, or at least a very small amount. After a pH of 7 we go into the basic scale, which we'll cover in the next lesson. This end of the scale encompasses all acids, the strongest at pH of 1 and the weakest around pH of 6 or 7. So what makes an acid, you may ask? Well, let's start with the definition of an acid. An acid is something that produces H+ or hydrogen ions in solution. The concentration of an acid tells us how strong the acid is, but not if it is a strong or weak acid. The strength of an acid is related to concentration, but whether an acid is strong or not depends on ionization, which we'll discuss later. Generally, the higher the H+ concentration in solution, the stronger the acid. If the H+ concentration is low, it's a weaker acid. This directly relates to pH. A high concentration of H+ means a low pH, and a lower concentration of H+ means a higher pH. So how does concentration differ from strength? Well, a concentrated acid is one that has a large amount of moles per litre or decimeter cubed, where a more dilute or less concentrated acid would have less moles per litre than a concentrated acid. For example, 0.2 moles per litre of hydrochloric acid is much less concentrated than 2 moles per litre of hydrochloric acid. We can calculate concentration by dividing the number of moles by the volume of the solution. This equation can be rearranged, so concentration multiplied by volume equals number of moles, or number of moles divided by concentration equals volume. These are extremely useful equations in chemistry. So what is a strong acid? Well, a strong acid entirely becomes ions in solution. In terms of ionization, it is 100% ionized. This means, for example, that hydrochloric acid turns entirely into H+ and Cl- ions in solution. Following this line of thought, a weak acid only partially dissociates into H+ ions and the negative ion. So, for example, formic acid, HCOOH, only slightly becomes H+ and HCOO-, so it is a weak acid. Common strong acids. In total, there are 7 strong acids, but you only need to know 3 of these for now. The 3 you need are nitric, HNO3, hydrochloric, HCl, and sulfuric, H2SO4. Interestingly, hydrochloric acid can be found in the stomach of most animal species, including humans, which means there is hydrochloric acid even in your own stomach. Any acid that isn't a strong acid is considered a weak acid. Common weak acids include acetic acid, CH3COOH, and phosphoric acid, H3PO4. Interestingly, acetic acid is the primary component of vinegar, except for water. Acids have many interesting reactions, which we'll cover in due course, but there is one we can cover right now. This is that acids react with reactive metals such as sodium or calcium and form a salt and hydrogen gas. For example, hydrochloric acid reacts with sodium to form sodium chloride and hydrogen gas. And what is sodium chloride more commonly known as? Why, table salt, of course. It's also important to note that strong acids and weak acids react similarly, just that weak acids react more slowly than strong acids due to a lower concentration of hydrogen ions. Well, thank you for listening to this first lesson. I'll see you all hopefully in the next lesson where I'll be discussing bases, the other half of the pH scale.